Okay.
Hi, Assalamualaikum and a very good morning to all. My name is Nur Sarah Farisha binti Man Isa, and today we will present to you about conduction graphical analysis on heat transfer, and we chose heatsink for DVD player as the application. Here are the contents throughout the presentation. We have introduction, design and simulation, analysis on a heatsink, discussion, and finally conclusion. Let me start with the introduction. So what is a heatsink? Where it can be used and what is the purpose of a heatsink and how does it work? A heatsink is a passive heat exchanger that transfers the heat generated by an electronic or a mechanical device to a fluid medium, often air or liquid coolant, where it is dissipated away from the device, thereby allowing regulation of the device's temperature. They are most commonly used in computers but are also found in cell phones, DVD players, and even refrigerators. In computers, a heatsink is an attachment for a chip that prevents the chip from overheating, and in modern computers, it is as important as any other component. The purpose of the heatsink is to keep the components safe from overheating. Heatsinks keep the temperature of the device at the desired range and prevent the accumulation of energy by absorbing it. Without heatsinks, most modern-day electronics would overheat very quickly and require costly repairs as a result. In the case of low temperatures, heatsinks can release thermal energy for adequate operation of the device. Heatsinks work by redirecting heat flow away from a hot device. They do this by increasing the device's surface area. In order for heatsink to properly work, they must have a temperature higher than the surroundings to transfer heat. Next.
Alright, I'm Muhammad Amar Bakir bin Zul Nazruddin. I would like to present the selection design of this assignment, which is we build, we make two design of the type of sink in SolidWorks application. For the design one, we use the aluminium material, which is the base of fin is 40 millimeters times 40 millimeters, and at the fin there are few hole which is 5 millimeters and 1 millimeters diameter, and then the gap within fin to fin between fin to fin is 5 millimeter. Center point arc for this design is 80 mm. Alright, we go further to design 2, which is the material for this design is copper. Then the base size of this fin also 40 millimeters times 40 millimeters. Then the height of this fin is 20 millimeters. And next we can see the figure of these two design of simulation. Next.
Okay, hi, my name is Muhammad Amir bin Ibrahim. So I want to explain about the analysis. First and foremost, as you can see, there are two types of analysis as we do two design. First, I want to explain the ambient temperature that we put based on the report. The ambient temperature is 31 degrees Celsius. The fin base size is 40 times 40 for the two design. The convection coefficient is 5.03 watt per meter square Kelvin. The average heat flux on the cold side is 1500 watts per meter square. The average temperature on the cold side is 76.6 degrees Celsius, and the average temperature on the hot side is 97.3 degrees Celsius. The picture shows the ranging temperature. As you can see, the red color is the hot side and the blue color is the cold side of the design. Next. I want to explain about the thermal loads. Thermal load is a temperature that causes the effect on the buildings and structures, such as outdoor air temperature, solar radiation, underground temperature, indoor air temperature, and the heat sources equipment inside the building. The heat flux is I want to explain about the heat flux. Heat flux is the rate of heat energy that passes to a surface. Depending the exact definition of heat flux, its unit can be expressed as either watt meter square or watt. The data show the convection and the heat flux. The entity phase is 90 phase and the convection coefficient for both design is 5.03 watt meter square Kelvin. The bulk and temperature we put also the same temperature that is 304 Kelvin. For the heat flux is 1500 watt meter per square. So next.
Hi, my name is Nurfara Fariza and I'm going to talk about discussion based on the result simulation. As you can see in the table, we selected two types of material. For design 1 is aluminium and for design 2 is copper. For design 1, aluminium, thermal conductivity 30 watt meter per Kelvin, and for specific heat 850 joule kilogram per joule, and density 3.960 kilogram meter cube. And lastly, for volume, we got 3.498 power of -2 meter cube. And for design 2, copper, we got thermal conductivity 390 watt meter Kelvin, specific heat 390 joule kilogram Kelvin, density 8900 kilogram meter cube. And for lastly, volume 3.3667 power of -2 meter cube. As you can see in the table, the comparison between the copper and aluminium. And for the design 1 aluminium, it is a good thermal conductivity. It is commonly used in heat sink because the material are more cheaper. And for copper, basically copper are more higher thermal conductivity rather than aluminium. But it is used where the higher level of thermal conductivity are needed. So thermal conductivity measures the ability of metal to conduct heat. Different type of metal is important to consider in application where high operating temperature are common. Temperature gradient in a body, heat will transfer from higher temperature region to lower temperature region transferred by conduction. As you can see, copper has around twice the thermal conductivity of aluminium, but copper is 3 times as dense and more expensive than aluminium. But we can say that copper are less ductile than aluminium, so it will cannot be extruded into heat sink. For the fin efficiency, we can also say that it contribute on higher thermal conductivity of material. A fin of heat sink considered to be flat plate with the heat flowing in one end and being dissipated into surrounding fluid as it travels to the other. Fin efficiency defined as actual heat transferred by the fin divided by heat transferred where the fin to be isothermal. That's all. Okay, we have reached the conclusion and we decided to choose design 2 as the best design. There are a few reasons why we choose design number 2. Among them are, first, the temperature range is less. This is due to the increasing of length and number of fins. Second, copper has a very high thermal conductivity of 400 watt per meter Kelvin. It is, however, heavier than aluminium and more expensive. But for operating systems that require an extensive amount of heat dissipation, copper is frequently used. And lastly, copper has the highest thermal conductivity because of its high melting point and a moderate corrosion rate. It is also a very effective metal for minimalizing energy loss during heat transfer. That is all from us. Thank you.
Cut.